So the question is, a ball is dropped from the height h above a point on an inclined plane with the angle of inclination theta. The ball makes an elastic collision with the surface and rebounds off the plane. Determine the distance from the first impact to the point where the ball hits the plane second time. So first we are going to draw the diagram for it. So in this case, there is an inclined plane making an angle of theta, and from a height h, this is height h, let us suppose we call this as A, B. The ball is dropped, and after making an impact at point B, it is rebounded the velocity of v. So let us call this as x coordinate, this will be y, and similarly we are calling this as y. So the angle with the vertical will be theta, and this will be also theta. So we can divide our initial velocity u into two components. This component will be called as u sine of theta, and this component will be called as u cos of theta. Similarly, the acceleration due to gravity g will be acting in downward direction, and it can be, this angle will be theta. So this component will be coming as g cos of theta, and this component will be as g sine of theta. So first of all, let us find out for path AB. We can say that as the ball is dropped from A, the initial velocity will be equal to 0. We can say that v square minus u square is equal to 2ah, where a in case of path AB will be equal to g. So v square will be equal to 2gh, and v will be equal to square root of 2gh. Now after making an impact at point B, it will be traveling with again the velocity v, because it's a perfect elastic collision, but it is going to have x component as well as y component. So in x direction, we can write it as u of x will be equal to v sine of theta, and a of x will be equal to g sine of theta. In y direction, we can write u of y will be equal to v cos theta and a of y will be equal to g cos theta. So first let's find out what will be the motion in x direction. Motion in x direction. The value of displacement, let's do it first in y direction. So value of displacement in y direction will be s of y, that will be equal to 0. So we are going to use the equation s is equal to ut plus half at square. So in y direction we simply put y. So s of y is 0, so we write 0 is equal to u of y is given as v cos theta and a of y will be minus, so we write here minus 1/2 g cos of theta t square, and this is multiplied by t. So from here we can find out t will be equal to 2v cos theta divided by g cos theta. Cos theta cancel with cos theta, so we get the time of flight as 2v divided by g. Now we in x direction. We are going to use same formula. S is equal to ut plus half at square. In x we are going to put simply as x. So s of x is equal to u of x is v sin theta. So we get this as v sin theta multiplied by t plus 1/2. A of x is g sin theta, so we get g sin theta t square. Now we substitute the value of t. We get equal to v sin theta multiplied by t, that is 2v divided by g plus 1/2 g sin theta square of time is 2v g whole square. So we can write this as 2v square sin theta divided by g plus half g sin theta 4v square divided by g square. G square goes with this g, this cancels out with 4, it will be 2. So we can write this as 2v square sin theta upon g plus 2v square sin theta on g. So s of x is equal to 4v square sin theta on g, and we already know the value of v, which is square root of 2gh. So we substitute here, we get this as 4 2gh sine theta upon g. G cancel out with g, so we get s of x, which will be nothing but the range, is equal to 8 h sine theta divided by g. This will be our, sorry, there will be no g. Final answer h 8 sine of theta. Thank you.